Hi, ho, Mr. Kaczynski with you. We're going to do the 5.4 practice your skills from our book. This is solving linear systems using elimination or the linear combination method. Here we go. Consider this equation, 5x plus 2y equals 10. What are the x and y intercepts? Okay. So to find the x-intercept, you just kind of plug 0 in for y, which would make that term disappear, and we get 5x equals 10, and then divide both sides by 5, and we see that the x-intercept is 2. To find the y-intercept, we would plug 0 in for x, which would eliminate that first term, and we get 2y equals 10. So the y-intercept would be 5 when we divide both sides by 2. So there's our x-intercept, and there's our y-intercept. All right, now multiply both sides of the equation by 3, then find the x and y-intercepts of the line. All right, so multiplying everything by 3, we'd get 15x and 6y and 30 instead of 10. So our x-intercept we could do 15x equals 30. And when we divide both sides by 15, we get x equals 2. And our y-intercept, we would do 6y equals 30. And divide both sides by 6. 30 divided by 6 is 5. So you can see here we get the same x-intercept as we got up here before we multiply both sides of the equation by 3, and the same with the y-intercept. How does the graph of this equation compare with the graph of the original answer? I guess the graphs of both equations would be the same. Multiplying both sides by the same number does not change the solutions to the equation. All right, use the equation 5x minus 2y equals 10 to find missing coordinate on each point. Okay, so we're given an x value here, and we need to find the y value or the a value. All right, so we're going to do 5 times 6 minus 2 times y, which is a, equals 10. So that's 30 minus 2a equals 10. Negative 2a equals negative 20 after we subtract 30 from both sides. So a equals 10 after we divide both sides by negative 2. All right, same idea here. Plug negative 4 in this time. This is going to be pretty repetitive here. So 5 times negative 4 minus 2 times y, which is our b value, or b this time, equals 10. So that's negative 20 when we multiply. Add 20 to both sides, we get 30. And divide both sides by negative 2, we get negative 15. Now, though, we are given a y value, and we got to figure out an x value. So we're going to do 5 times an unknown x, or in this case, c, minus 2 times y, which is 25, equals 10. So 5c minus 50 equals 10. 5c equals 60 when we add 50 to both sides, and c equals 12 when we divide both sides by 5. Again, we're given a y value. So let's do 5 times d, that's the x value, minus 2 times negative 5 equals 10. 5d plus 10, negative 2 times negative 5 is positive 10, equals 10. 5d equals 20 when we add 10 to both sides. So d is 4 after we divide both sides by 5. All right, got an unknown x value, so we're going to do 5 times e minus 2 times 0. That's going to make it a lot easier, isn't it? Equals 10. And we basically already did this. 5e equals 10, so e equals 2. That's basically the x-intercept, which we got right there. X equals 2. And one more here. 5 times our x value, which is 10, minus 2 times our y value, which is f, equals 10. That's 50 minus 2f equals 10. Subtract 50 from both sides. 10 minus 50 is negative 40. And then divide both sides by negative 2. Negative 40 divided by negative 2 is 20. So f would be 20. Solve each system of equations by elimination. Well, this first one, you can see that when we add these two equations up, 6x plus negative 6x is just going to give us 0. So that's good. So we'll get 5y plus negative 10y is negative 5y. And then we'll do negative 20 plus 25 is positive 5. And when we divide both sides by negative 5, we get our y value. Now we just got to figure out our x value. So let's do 6 times x plus 5 times that y value that we just found equals negative 20. So I've plugged that negative 1 into the top equation. You can do either equation though. So it's 6x minus 5 equals negative 20. Add 5 to both sides and you get 6x equals negative 15. And divide both sides by 6 and we get, give myself some more room here. Negative 15 divided by 6, that's going to be a fraction. About negative 5 halves. So our solution then will be x is negative 5 halves and y is negative 1. Let's check our answer here. We already know it's going to work in the top equation, but let's plug it into the bottom equation. Negative 6 times negative 5 halves minus 10 times our y value of negative 1, and this should give us 25. It does. So we know it's right. All right, over here on the next one. I think I need to take this top equation and multiply it by 2 so I can get an 8y. So it's going to give me 10x minus 8y equals 46, doubling everything. The bottom equation I won't change at all. 7x plus 8y equals 5. And now I'll add these two equations together because the y's cancel out. So that gives me 17x equals 51. 51 divided by 17 is 3. So that works out pretty nice. X is 3. Now we just got to figure out what y is. So I think I'll come over here and I'll plug that 3 into the bottom equation. Again, you can do either equation. I like this one because the y's got a positive coefficient there. So it's 21 plus 8y equals 5. Subtract 21 from both sides. 5 minus 21 is negative 16. And then divide both sides by 8. And we get negative 2. So our solution here is when x is 3, y is negative 2. We know that works in the bottom equation. We just used it here in orange. Why don't we plug it into the top equation? 5 times 3 minus 4 times negative 2. And this should give us 23. It does, so we know we've got the right equation. Anisha turned in this quiz in her algebra class. What method did she use? Looks like she used substitution here. She put this x minus 5 in for y right there. So she used the substitution method. What is missing from her solution? Well, she found x, but she didn't find y. So the y value of the solution. So all we got to do is complete her work here. Okay, so she already found that x is 4. We just need to figure out what y is. Y is x minus 5. So y equals x minus 5. So y equals -1. So her solution is 4, -1. And let's plug it into the second equation just to make sure. Let's do 3 times the y value, -1, plus 2 times the x value, 4. And this should give us 5. It does, so we know we've helped Anisha get the correct answer. All right, we got this system of equations. Explain how you could eliminate the x term when you combine the equations. So we would want the x terms to be opposite. So I would think like least common multiple of 3 and 5 would be 15. So here's what I'll say. Multiply the top equation by, let's do it by -5. That'll give us a -15x. And the bottom equation by 3. That would give us a +15x. Now we could multiply the top equation by +5, but then we'd have to multiply the bottom equation by 3. Explain how you could eliminate the y values. So let's look at 7 and 8. The least common multiple of 7 and 8 is 56. So I want to get one of them to be -56y and one of them to be +56y. So I'll say multiply the top equation by, let's go -8, and the bottom equation by 7. Again, you could multiply the top equation by +8 and the bottom equation by -7. That would work as well. All right, I've talked long enough. Hopefully that helped and you've caught your